Welcome back, everybody. For this section, we talk about Earth's interior and how it relates to earthquakes. So the question here is not just what do we know about the structure of Earth's interior, but also how do we know it? If nobody has ever been to the core, then how does anybody know what the core is made out of? And the answer here all has to do with something called remote sensing, right? Remote sensing. So we cannot directly go to the interior of the Earth, and it's very expensive to go even just a little bit into Earth's surface. So it has to be investigated from far away. It has to be sensed remotely. Seismic waves, earthquakes, and all of the different stations on the Earth that can listen to these earthquakes put this enormous amount of data together in order to be able to analyze the structure of Earth's interior. So let's take an example here. We have an earthquake in Kobe, Japan. It releases P waves and S waves out in all directions. Now, the P waves are going to travel along, they're going to hit all of these different listening stations here and here, but something happens physically when it hits the outer core. The P waves start to deflect sideways. In other words, they deflect so far that there is this shadow zone, P wave shadow zone. So none of the ears in this station, the seismographs, are able to detect P waves because whenever one of them would get there, instead it gets deflected by the outer core and comes all the way over to here. Now with S waves, this is even more pronounced. So S waves cannot travel through a liquid. This is actually in part how we know that Earth's outer core is liquid, because the S waves seem to come to it, and then they just vanish, they get reflected. So there's this entire S wave shadow zone over here on the other side of the world that is being blocked by the fact that the outer core is liquid. Some of the waves are going to come here and bounce off, others are going to barely miss and get to about here, but none of the ears in this part of the world are able to hear the S waves. So this is not the only way that we can have some knowledge about what is going on deep in the Earth. Another way is to look at magmas, or the products of magmas, whatever is left behind whenever a magma cools, called an igneous rock. And by studying these, we can have some idea of what is probably going on deep inside of the Earth, because that is where these magmas are coming from. The final way that we can do this is to go out and drill a hole. This is very expensive. If you want to know something about the geology of an area, drilling a hole is maybe the final step that you would take because, well, maybe $1 million to drill a hole is a good ballpark figure. Now, one very deep and very expensive hole is called the Kola Superdeep. This is the deepest that humankind has ever gotten into the Earth. This is a hole about 12 kilometers, about 8 miles drilled. This was actually context of the Cold War. So the United States and the Soviet Union were competing in all sorts of different areas. They have the space race, and they also have kind of the opposite to see who can go deepest into the ground. It took maybe 30 years to drill this thing, and despite the fact that it was started in the 60s, it is actually still the deepest hole on Earth. And the video here has more information if you like. So this is actually a picture of the Kola Superdeep station in Russia. This is where it would have been drilled, and this is what it looks like nowadays. Kind of abandoned, not being used. There was some scientific research done as a result of the Kola Superdeep, but it's not really being used for anything today. Just a big hole in the ground that nobody wants. For the final section, we talk about measuring earthquakes.